Okay, so we're going to start with practice 2 using the energy equations that we've gotten from the development. And we're going to use this 5-step process, and it's listed here. And we started this problem in class, but this is just a really good review for if you wanted to make sure that you got everything that we talked about in class, or if you were absent. This is a problem that we did together already in class, okay? So we'll start with the first one, which is a hockey puck of mass 0.2 kilograms is traveling at 20.0 meters per second. What is the kinetic energy? And so this is our question here. What is the kinetic energy? And we're going to go with each step. So step 1, draw a sketch. Okay, so step 1, we're going to draw a sketch of our hockey puck traveling. So here's the ice. And here's our hockey puck, which is traveling. There it is. And it has a mass of 0.2 kilograms and a velocity of 20.0 meters per second. Okay. The next step is what are you trying to find? What is the unknown here? And we already know that the unknown is what is the kinetic energy. So the unknown is our kinetic energy. Step 3 is listed given information, which we did. Whoops. So this was step 1, this was step 2, and this is step 3. Step 4 is what is the mathematical relationship. So we're going to go ahead and think about what equation has E, K, M, and V. And so from the lab, we remember that the kinetic energy is equal to 1/2 mass times velocity squared. And then we're going to go ahead and take the time now to solve that. Okay, so we have EK. EK is equal to 1/2 mass, which is 0.2 kilograms, times velocity, which is 20.0 meters per second squared. So just thinking out loud, we have EK is equal to 1/2 times 0.2 kilograms times 400 meters squared per second squared. Okay, we have half of 400 is 200. 200 times 0.2 is going to give us 4 with a 0, so that will be 40 joules. So our kinetic energy with these givens will be 40 joules. Now for the proportional reasoning, we're going to use these values as our original values. Okay, so these values right here are original values. And that's what we're going to use when we're called for an original value here. Okay, so given the same velocity, so the same velocity means that this number is not going to change, so anything multiplied by 1 is going to be the same. What is the kinetic energy if the mass of the puck is 0.4 kilograms? So our mass was 0.2, and it became, the new one is 0.4. And so what happens is 0.2 times 2, 0.2 times 2 will give us 0.4. So we'll have a 2 here for a coefficient. 1 squared times 2 will give us 2. And so we have, let's see here, our coefficient of 2. This is what's going to go here because it's asking for what is the kinetic energy. So we want to know the new kinetic energy. So 2 times our original value was 40 joules. Going to be 80 joules. Okay? And so then the next part of this problem is given the same mass, so now our mass is going to stay the same. What is the kinetic energy? So this is the stuff that's going to go down here. What is the kinetic energy if the velocity of the puck is 40 meters per second? So we were at 20 meters, and then we got to 40, so we're going to have to go times 2. So 2 times the velocity. Now, let's solve for this first so that you can see where the numbers are going to come from, okay? So we have an EK is equal to 1/2 our mass, which is the same, so 0.2 kilograms, times double the velocity, which is 40 meters per second squared. So when we do the math, we have 1/2 times 0.2 times 40 times 40. So we have 1/2 times 0.2 kilograms times 40 times 40 is 100, so 1600 meters per second squared. Square that. We have, so 1/2 times 0.2 times 1600 will actually give us 160 joules. Okay, so this is our new value. Our old value was 40 joules. Now to get from 40 to 160, we multiply it by 4. So we have 40 joules here, 160 joules, multiply by 4. Look here, 2 squared is going to give us 4 times 1, and we ignore this. So 4 times 1 is going to give us 4. That's the end of that problem.